Hi friends, let's have a look at today's daily challenge problem. So maximum beauty of an array after applying operations. So basically, for this problem, for each index, you can do at most one operation. That is to change this number either to a number in the range given by this number minus key and this number plus key. So this is the closed interval, right? So here, the beauty of the array is the length of the longest subsequence. So here we are considering subsequence consisting of equal elements. So we want to return the maximum possible length of a beautiful array. So after we apply those operations, for sure. So here are some examples. So the second example is very easy to interpret, right? So all the elements, they are equal, right? So the output is 4. And for this one, the maximum length is 3. So this is an explanation. You can change all the numbers to be 4, right? So 3 of them are false. So because we are considering subsequence, so the length is 3. So with that said, I guess we are ready to explain the main methods. So here I'm going to do two methods. So the first one is the two-pointer sliding window method. So actually this is a method actually directly come to my mind when I saw the statement of the problem. And secondly, if you think a little bit deeper, so you can see the method 2. So this is a very classic method or algorithm called line sweep. Right, so we are going to first explain this one because this one overall a little bit faster than this one. So, but time complexity wise, they are the same because we are going to involve certain sort. Right, sort is a logarithm n times n algorithm. Right, so the first question we want to answer is that so if we want two numbers to be equal at the given operation, so what are the conditions? What's the condition? So here I have two number a, b. So each number you can deviate by key, right? So then we can assume a is less than b so that we can fix the idea. So a actually corresponds to a interval and b also corresponds to the interval because a and b can be any numbers in the corresponding intervals respectively. So the two intervals overlap, right? It means that the two numbers can be equal at the operation. So it means that the start of the second interval is less than or equal to this guy, right? So it's b minus k is less than or equal to k. In other words, the larger number b minus the smaller number a is bounded above by 2 times k. So this is the condition. So in general, if you don't want to distinguish the which one is bigger for the two numbers a and b, so the condition will be the absolute value of the difference is bounded by 2k. So this is the one question and claim. So the second claim is that if we sort the array numbers, so we can sort it because the problem statement, because we are considering subsequence, right? So if we sort the array and then we actually produce the numbers because the array will be, for example, non-decreasing, right? So we just need to find the longest subarray. So for example, the array starts at index L and end at index R, such that the largest one minus the smallest one is bounded by 2k. And because the array is sorted, then all the numbers in between will also be bounded by 2k, right? I mean, there are difference, right? So this way, we can make all the number in this range equal. So for each left index R, L, we can find the corresponding R, right? And then we can find the maximum length. So another thing is that once arrive at this stage, you should be able to realize that we can use two-pointer sliding window because monotonicity. So we have L and we have a corresponding largest R such that this condition holds, right? Then if we have L bar, which is greater than L, right? And then so R bar, the corresponding R, should no less than the previous L. So this gives us the monotonicity to avoid repetition. So we can use two-pointer sliding window method. So this actually is a correctness proof or reasoning. So let's first do the two-pointer sliding window method, and then we explain the second one, right? First, let's get the length of this array. So this is just for convenience, and then we can do a sort. So here we sort in place. So by default, this will be sort in increasing order. In other words, the resulted state of nums will be non-decreasing. So then we can find a length of the longest such subarrays, say nums. So starting from index L, ending at index R, such that so the nums R minus nums L is bounded by 2 times key, right? So this is rather straightforward. First, let's use a result. So we're going to return the final state of this result. This result will compare the different resulted longest subarray lengths, right? And then we have the R pointer that is 0 originally, equal to the L, right? And then what we want to do is for each left index, so we want to find the corresponding R, right? So we know that R should be at least L, so we can make it sure. So maximum R and L, right? So in other words, we start from L. So basically, we can write a while loop. While R is less than N, right, in bound. So we can consider nums R at index R, and nums R is less than or minus nums L is less than or equal to 2 times k. If this were the case, we're going to increment this R. So if we examine the conditions or the situation we get out of this while loop, so either R is N out of bound, or so we have this, the R is such that this condition is not hold. So in other words, R minus 1 will be the ending index, right, for valid. Here it's actually subarrays, right, because we have to make the sort. So nums L, so R, so or end, right, start and end. That might be better. So R minus 1 will be corresponding to the end. So for this case, then we compare the longer ones. So R minus 1 is the ending index. L is the start index. So the number element will be R minus 1, the end index, minus the beginning index, then plus 1, right? So the two ones actually cancel. So we just get R minus L. So then we just need to return this result. So this is a full code. Actually, if you realize the main logic, the code is actually very short. So let's do a test. It passes one example. So now let's look at the generic case. It passes all the cases. So this is the solution we want. So this is based on two-pointer sliding window, right? So now let's look at the second way. For the second way, so I'm going to use line swap. So actually, you can see this is the one solution in Golang, and also you can see this leetcode post. So overall, the idea is this. The idea is, so if we have a number of ranges, or for example here, intervals. So if we have ranges, and we want to count overlaps. So how many of them, what's the maximum of them overlaps? So we just need to focus on the start and the end, right? So for example, if we start at 1 and 2 and 3 and then extend to infinity, then the largest overlap will be 3, right? But if we have a stop at 2, then the largest overlap will be 2, right? So let's see how we can do this. So let's first let's use line swap. So I can make a list. So how do we make the list? So to monitor the start and end of the corresponding numbers or corresponding intervals, right? So then what we can do is for y in the nums. So what I want to do is so in order to get all the starts, so I appended this one. So it's y minus k. So this is the minimal, right? So because it's the start, I'm going to count it as 1. So another one is that I want to append also the end. So the number will end at, actually this is included because of closed interval. So I'm going to add 1 because this is the end, say x coordinate, right? So and the y plus k is belonging to the previous interval. So once we get out of larger than y plus k, then we're going to decrement 1 overlapping if possible. So this will be the line overlap. So we need to make a sort, right? So in place, I'm sorting according to the say x coordinates. You can understand like this, and then you will get. Let me print out this for you to visualize or inspection. So for example, 4 is corresponding to 2 and 1, right? You have 2 and 1. And 4 actually have corresponding to another end is 7 and negative 1. So you have 7 and negative 1. Similarly, 6 will be corresponding to a 4, 1, right? And 9, negative 1. And 1 corresponding to negative 1 and 1. And also corresponding to 4 and 1. 1 plus 2 plus 1, right? That's 4, right? So this one, I guess it's corresponding to 0 and 1 and 5 and negative 1, right? So here I guess I might make some mistake. 6 corresponding to 4 and 1 and also 9 and 1. Yeah, that's right. So once we have this, so then once we met negative 1, we have a new interval start. So we count the overlap by 1, and then we met 0, we count the 1. So the 1 plus 1 is 2, and at this one 2, we get another index. So it's 3. And then at 4, there's index, there's interval end, so the overlap will be 3 because so 1, 1, 1 minus this one, it will be 2. Then at this 4, another interval starts. So we have, because we are considering closed interval, then the count will be 3, right? So then this one will be negative 1, so we have 2, and this one we have 1, this one we have 0. So once we are greater than or equal to 9, there are no intervals, so of course you have 0. So so this is the main idea. So now what we want to do is that let's see, I have a result. So this is a counting variable, and then what we want to do is so we are only care about the increment for count in so it's possible that for each index for each x coordinate maybe the start or end of several intervals. So in other words, the second component can be larger than 1 or smaller than negative 1. So if you look at this one, for example, so let's first in line swap, let's pass it. Let's I think I print line swap, right? So you have something like this. So right, so 1 1 1 1. So at 9 you have 4, right? And then at 12 you are going to decrement. So after you got larger than or greater larger than or equal to 12, you get 0 intervals. So it's better maybe comment out this one. And then what we want to do, so current 0. So we are going to increment the current by count, and then we compare, update the result to be the previous state and the current. Then we just return the result. So this is a very simple application of line swap method. Let's test it. Let's see, I changed this one to be version v1, and then let's do yeah, it passes, but it's slightly using more time. I guess because here the sort will sort in two elements of length 2. So then I want to have an extension before we end this one. So this problem can also translate to such a problem. So actually this is also what we solve it. So it's just maybe as an extension or remark here. So let's use this one as a demonstration. So I can transfer this to be 2 and 6. Notice that I'm using 6, not 7, right? So 6, I can translate it to 4 and 8. And then 1, I can translate to -1 and 3, right? So 2 going to be 0 and 4. Then the question is, what's the maximal number of intervals? So here the intervals are closed, right? Say overlapping. So this is actually another statement of this problem. I guess you can see from the original statement up to here. So the major point is reduction or transform of the problem, right? So I guess that's the major point I want to emphasize within this video. With that said, I guess you can try to solve this problem without using 2-point sliding window and without using line swipe, but consider this one to find the largest number of closed intervals that are overlapping. So with that said, I guess we expose sufficient information for this problem. Thank you very much for watching.